Hello, this is Mr. Sumter for our e-learning day on Tuesday, January the 12th for our Algebra half class. We did have a quiz scheduled for today, but we'll be taking that tomorrow, so instead we're going to move on to the next chapter, which is chapter 5. And so this is for lesson 5.1. Okay, got to get back. It's been a few weeks, a couple months actually, since before break that we've been talking about functions and things like that, so we need to do a little bit of review here. If you remember, a function, if we have it in a table, a function, the x's do not repeat, right? Remember that? And if it's graphed, a function, we can tell by it if it passes the vertical line test or not. So if you can draw a vertical line at any point and it crosses more than one spot, then it's not a function. But remember, if it's in a table, x's can't repeat, and the vertical line test. So a couple of little review there. Today we're going to talk about specifically linear functions. Okay? Linear, if you notice, the root word there, line, a linear function, its graph makes a straight line. And this doesn't mean any kind of curve at all. It means perfectly straight line, okay, for it to be a linear function. And it can't be vertical. Like a linear function couldn't be a vertical line because it wouldn't pass the vertical line test. So a little trick there with that. By the way, I apologize for the video being a little rickety. I'm holding an iPad while I do this and doing the best I can. So hopefully that you can still understand and see what we're doing. By the way, these notes are also posted online, so if you want a better look at them, you can see them there. Alright, so function. Is it a function? Is it linear? First of all, it passes the vertical line test. I can only draw a line going through one point, so it is a function, and it makes a straight line. Granted, my line isn't perfectly straight. I didn't do a very good job there. Should use a straight edge, but that is a linear function. Again, 1b, it does pass the vertical line test, so it's a function, and it makes a straight line, so it's linear. 1c, it does not pass the vertical line test, so it's not a function. Notice if I draw a straight line down, it would cross at two spots. So it is not a function, and it's also not linear. Okay? Alright, so that's just looking at a graph to tell if it's a linear function or not. We can also tell by using a table or a set of ordered pairs. Okay? For it to be linear, linear functions have a constant change in x that creates a constant change in y. So that means if x is going up by the same number each time or going down by the same number each time, and y goes up or down by the same number each time, they don't have to both be the same. X can be going up by 3 each time, and y can be going down by 4 each time, but as long as their x's are all consistent and y's are all consistent, that would be a constant change in x producing a constant change in y, and that would make it a linear function. And keep in mind, the rule must be add or subtract. So on the first example here, our ordered pairs are 3, 5, 5, 4, 7, 3, 9, 2, 11, 1. Comparing the x's, I'm looking at the 3, the 5, the 7, the 9, the 11, and you can see I wrote up here, they're going up by 2 each time. Right? On the y's, it goes from 5 to 4 to 3 to 2 to 1. And so those are going down 1 each time. So a constant change in x is creating a constant change in y. And so this is, yes, it is linear. You can also do the same thing with a table, except our ordered pairs are written vertically. So the x's are going up 1 each time, from -2 to -1, 0, 1, and 2. However, look at the y's. From 6 to 3 is going down by 3. From 3 to 2 is going down by 1. Down up to 3 is going up by 1. And then up to 6 is going up by 3. So those are all over the place, not constant, so this would not be linear. Okay? So again, looking at a graph and telling if it's a linear function, and looking at the ordered pairs to tell if it's a linear function or not. The last thing you can do is look at the equation. Using the equation to determine if it's linear. This is really quite simple. If it's just a plain old x and y in the equation, it's going to be linear. If there's something crazy in there, then it's not going to be linear. Okay? So here's what I mean by crazy. To be linear, it can't have any of these. So no absolute values, x raised to an exponent. So like x to the third power, x to the second power, can't have that. X can't be in the denominator, so you can't have y equals 5 over x. You can't have x in the denominator. Or x as an exponent, like y equals 5 to the x power. Okay? So any of those happen, it's not linear. If it's just a plain old y and a plain old x, and some other numbers in there, then you're fine. So the question says, is it linear? If yes, then graph. So the first one, y equals 5x minus 9, there's none of that other stuff. There's no absolute values, there's no exponents, there's nothing crazy. That is linear. As you can see, I have it there. Y equals 12. Although there's no x, that is also linear. 3c, y equals 2 to the x power. There's something different. X is in the exponent. So that would not be linear. Now it does say to graph these. So I'm going to back up here. We're going to review how to graph this one in just a second. Okay, y equals 5x minus 9. On 3b, y equals 12. This one's a little bit trickier to graph. Instead of making a full table of pairs, ordered pairs, all you need to do is make a little t-chart. This means that y is always 12, no matter what x is. So I just put y is 12, 12, 12. I made up my own x values. -4, 1, 3. I made those up. So for instance, I could plot -4, 12, and I just kind of approximated on this little graph. 1, 12 would be about there. 3, 12 would be about there. And as you can see, it makes a horizontal line. Okay? And again, I got a little note here to remind you, if the graph only has one variable, make a little t-chart and just put that value in. If this was x equals something, then it would always be x would be 4, 4, 4 or whatever, and then you could make up your own y values. And the x equals would be a vertical line. It's not a function, but it would be linear. Okay? This last one here, 3a, let's review how to graph this. Remember to make a table. So we've got x, we've got 5x minus 9, and we've got our y value. And then that gives our ordered pair x, y. So we're going to make a table of values here. I'm just going to make up some simple x's. So let's just make it easy. Because I know it's a line, because I know it's a function, I don't need to worry about u's and v's and all that we did before. Just use simple things like 0, 1, and 2. So if I plug in 0 for x, I get 5 times 0 minus 9, and that would be 0 minus 9 is a -9. So my ordered pair is 0, -9. So I'm going to put that here, 0, -9. It's my ordered pair. If I plug in 1, I get 5 times 1 minus 9. Well, that's 5 minus 9, which is -4. Feel free to use your calculator. Some of you still struggle with 5 minus 9. So my ordered pair would be 1, -4. Shh, guys, be quiet. My next video, 5 times 2. I'm plugging in 2 for x minus 9, which would be 10 minus 9, which is 1. So this last ordered pair would be 2, 1. And then you can graph these points on a grid, on a graph, 0, -9, 1, -4, 2, 1. By the way, we know it's supposed to be linear. If I graph it and it's not linear, that means I made a mistake if it doesn't make a straight line. Okay, so that's how you do that. So again, by looking at the graph, by just looking at the equation, we can tell if it makes a line or not. If it is a line, then we have to graph it. The next section in the notes, these are online, but you do not have to worry about this next section about standard form. So I'm crossing that out. So you cross that section out, you don't need to worry about standard form. Okay, that's an algebra concept that we don't need to worry about. And again, here's some more of these that it does say to put in standard form, but just to review, this would be linear because there's no nothing crazy in it. There's no y. It would not be a function because this would be a vertical line, but just kind of going back to what we were talking about a second ago, this one would also be a line, right? Because there's no squareds, there's no absolute values, nothing crazy, but that would also be a line. Last thing, a little note about story problems, okay? Use a reasonable domain. Remember, domain is our x values. So our x values is our domain. So if it gives you in the problem, gives you some sort of parameter about how many times you can do something or how much money you have to spend or whatever, that's what you're going to use for your x values. It might say the person can only rent so many videos a month, up to 5 videos. So you could rent 0, 1, 2, 3, 4, 5, and you'd plug that in for your x's, okay? Keep in mind with real world problems, you usually can't have a negative number. Okay? And then when you graph these, you want to plug in a few points to find a pattern and then graph. Make sure that to label your graph when you graph it. So a couple of notes about when you graph. Plug in a few points to find the pattern, make your graph, make sure you label the graph. You usually have to make up your own equation. We've been doing equations all year. Remember, y is usually going to be your total. Okay, so it's going to be y equals something. Y is your total. That's usually what it's going to come out to. Okay, So I got a homework assignment listed on Google Classroom. Do your best. Again, these notes can be found, a copy of these can be found on my website, as well as you can look at the online textbook resources, use their examples for lesson 5.1, or use their lesson videos for 5.1. A lot of better examples there as well. Okay, have a good day.